want to be able to do calculations with the data and do curve fitting to the data. So here I have an example where I will import some data into Mathematica, and so we get a list of data returned. And so what I want to do here is change the value of two of the points in this data so that they are outliers in the data. I hope everyone can understand that. Perhaps you'll understand what I mean when you see the plot in 1 minute. So we change the value to create some outliers. And so here we see these outlying points. So what happens when you want to try and do a curve fit a model to data that contains outliers? So one thing you can do is manually just remove those points from your data. But maybe you don't want to do that. So if we do a standard least squares fit, we have a function called find fit. And so we see here that, so we see that the line is not really a very good fit because these 2 points are included in the least squares fit. So in a real experiment, you might decide, well, there was something wrong there and those data points, we don't want them. So what we can do is to fit to a different normalization function. And so the default way of normalizing in find fit is this expression here for the least squares. If we change that to this expression, then we can see that Mathematica gives us a much better fit this time once we change that expression, and we don't have to worry about these outlying points. Okay, so here I've got another example, some data. This time this data that I've imported is deliberately noisy, and what I'm going to do is use another Mathematica function called linear model fit to try and fit a polynomial to this noisy data. And so I get a fitted object model returned. Now, one of the things about linear model fit is that when it does a calculation, it doesn't just, in this case we've asked for a polynomial fit of the data,